Okay, so let's talk about cache mapping techniques. I will talk about three techniques. The one is the direct mapping, the second is the set associative, and the third is the fully associative. We have some extremes. One extreme is the direct mapping, the other extreme is the fully associative, and between them, like combining the two, is the set associative cache mapping technique. So if we understand, all we are talking about is cache mapping technique from the main memory to the cache when the CPU wants some data from the memory. So in direct mapping technique, what we are doing is taking the data from the main memory and looking on its address. In its address, we are taking some of the lowest digits to form the index, and by the index we know where to put it in the cache exactly, namely for this index. If we have, for example, a cache of, let's create it, okay, let's make it 4, for example. Maybe it will make something not good. So if we have, for example, index 0 0, so it will come from here, 0 1 it will go from here, 1 0 will go from here. If we, and then when we don't have any place, so we are starting over, so this will be 0 0, it will go from here, and this one will be 0 1, it will go for here. You can see that there may be some replacement. I mean, if I take this data, this block of data, and put it right over here, and then the CPU wants this data, so this will also be mapping to here. But if we already mapped here to this, we will need to replace them, and of course it takes time. Now all this area is called the tag, and if we already have it in the cache, so it will be tag hit. But if we take something that we don't have now in the cache, so it will be cache miss. And this is the idea of direct mapping, exactly to where we want. It's quite efficient, but there may be some replacements. Now we're going to the next extreme, which is the fully associative. What we are doing here is just taking this is the main memory, and this is the cache. And what we're doing here is just putting every memory that we can in the place there is. All the cache is available, and everywhere there is place, I will be able to put the memory that I want. If this, for example, I want it, so it translates to here. If this goes to here, and this one goes to here, and we have only this left, so this one will go to here. You can see that we don't have the problem of, for example, if I take this block and put it right over here, and now I'm using this one in direct mapping and tell me you must put it here, even if it means that you need to replace, and even if it means that there is a place that is empty now, for example, but you won't put it here because the index will tell you to put it here, even though there is already data here and you need to replace. In fully associative, no, I can put it wherever I want. So of course it will be a little bit harder to find things, because here you have indexes, you know exactly where every block will go to. Here you don't know, because every block can go to wherever you want in the cache. So in order to compromise between those two methods, between the direct mapping and fully associative, we have the set associative. When we're talking set associative, we're talking about n-way associative. The way associative is what are the size of the set. In two-way associative, for example, we have sets of 2. What does it mean? It means that for every block, instead of telling exactly where it will put, in which line it will be put in the cache, we will tell for each block where you will be in the set. You will be in set, for example, 0 0 or 0 1. So if, for example, I have some data that will be for set 0 0 and another data that will also go to set 0 0, so this one can go right over here, and that one, instead of just writing on this and overriding it, we can put it in the second block in the set, in the same set that is free. So I can put, for example, let's call it 0 here, and 0 1 2 3 and 3 right over here. So now, like for a specific index, we have 2 places, so 2 memories can go in the same index. So it's a little more letting little less harsh than the direct mapping. But yet, when I want to find something, I will be able to go to the set, and then I will have much easier time to find the data compared to the fully associative. So this is the advantages and disadvantages that it's like combined between them. Of course, if I need another data that also will be in set 00 and those two are full, I need to replace one of them, of course. But it's like a compromise between those two methods, between direct mapping and fully associative. So this is the set associative, and this example will show you the n-way set associative. I could also do 3-way, and then each set will be, instead of 2 lines, it will be 3 lines. Okay, so this was about the cache mapping techniques, the direct mapping, very direct and harsh, the set associative, combining the direct and fully associative, and the fully associative, each block from memory can be everywhere in the cache, and the disadvantages and advantages of each of them. Thank you very much, and that's it. Of course, if there are any mistakes or corrections, please tell me. Thanks for now.